All right, so in this video, we're going to be using long division before we use partial fractions because our top degree is bigger than our bottom degree, and we have a quadratic here. It's not that linear x minus r form that we can use for synthetic. So let's get started. So we're going to first divide the top by the bottom because the degree is bigger. And now we're missing a 0x squared, so we need to put that in there as a spacer. And then we do x squared minus 3x plus 2. And then we verify everything is correct as we've transferred it. So plus 0 minus 4. You make one mistake here, then all that work you did is wrong, and you got to go back, erase, fix the whole thing again. And in my case, I've got to redo the entire video, which I really don't want to do. So now let's do this. So x squared into x cubed, that would be plain old x. And you can also tell what it is by just counting. We have 1, 2, 3 terms because it's a square. So we know there'd be 3 there. 1, 2, 3 right there. See how it's x? Matches perfectly. So now we multiply it and we get x cubed minus 3x squared plus 2x. And then we change the signs. So minus, plus, minus, and that would be cancel. That's what we wanted. 3x squared minus 6x plus 1. And then we continue on. So the next one's a constant. So x squared times what would be 3x squared? That's plus 3. So we end up with 3x squared minus 9x plus 6. Change the signs. Those cancel. And we end up with 3x minus 5. And so now we know that our divided would be x plus 3 plus 3x minus 5 all over x squared minus 3x plus 2. And this is what we're going to use to make the partial fraction. So we're going to use that part. So the x plus 3 is ready to go in our integral. So let's transfer it over there just so we have our steps. We have the integral of x plus 3 plus 3x minus 5 all over x squared minus 3x plus 2 dx. And now we can use that as our partial fraction. So first thing to do is take our little 3x squared plus 3x minus 5. This is step 1. This is our step 2 over x squared minus 3x plus 2. And we're going to make our partial fraction. So what is that factored form is what we need to know. So this would be x minus 2, x minus 1. And that would give us x minus 2, x minus 1. So we're going to take a and multiply it by x minus 1. And we're going to take b and multiply it by x minus 2. And then that will add up to give us the top, which is 3x minus 5. So we end up with ax minus a, bx minus 2b. And so that means a plus b has to equal 3. And negative a minus 2b has to equal negative 5. So if we plug that into our matrices, this would be 1, 1, 3, negative 1, negative 2, negative 5. Or we could just solve it. And in fact, let's solve it since we didn't do it that way before, but you can use that matrix if you want. This is nice and quick. A minus a, and then this would give us just negative b equals negative 2, which means b equals 2. So it was nice and quick. And then that means a plus 2 equals 3. Subtracting the 2, a equals 1. So this was a nice, clean linear systems of linear equations. So we could do it very, very quickly. So let's circle those so we don't plug any other numbers in that we're not supposed to. It just gets it cleaner. So this would be 1 over x minus 2 plus 2 times 1 over x minus 1. So that means our a here is equal to 1. Our b is equal to 2. And so when we plug those in, we end up with the integral now of x plus 3 plus, and then it's 1 over x minus 2 plus, and you can leave the 2 because there's nothing underneath it, so we can actually write it nicely this way, x minus 1 dx, and let's double check this. So yes, our a we got as 1, our b is 2, so it'd be 1 over x minus 2 and 2 over x minus 1. So far, everything is good. So this is 1/2 x squared plus 3x plus natural log of x minus 2 plus 2 natural log x minus 1 plus c. And there you have it. So if our top degree is bigger than your bottom, you're using long division if your bottom is not x minus r. And then that will break it up and give you the fraction that you can actually use partial fractions on. Once you break it up, you can then finish it off.